Guys, in the last unit we talked about how to go from two binomials like x plus 3 and x minus 2 and multiply those together and get to a single polynomial like x squared plus x minus 6. Going this way, we call that multiplying binomials or multiplying polynomials. If I were to go backwards on this, so if I were to take my trinomial and move back to a pair of binomials, we call that factoring. When we factor something, when we factor an expression, what we do is we take that expression and we break it down into the component pieces that could be multiplied to give us our expression. It sounds really complicated, it sounds really strange, but it's actually pretty simple to do. So let's go ahead and get started on that. If I give you a problem like, let's say, x squared plus 5x plus 6, the first thing you're going to do is remember SPI. Sum, product, integers. Now, a SPI chart, ladies and gentlemen, is absolute genius. So watch how easy this is. I've got a sum, I've got a product, I have integers, now I just need to find out. In the column for sum, we always take the coefficient of x. So in this case, that's 5. What that means is whatever my two numbers are. So when I look at my final binomial, I'll have x plus something here, x plus something here. Whatever goes on these two lines, those two numbers have to add up or give me a sum of 5. Now our product is the constant, so in this case that's 6. So again, whatever these two numbers are, need to multiply or give me a product of 6. So now the final column over here is where we can pick our possible integers. So let's go ahead and set that up. I always start by looking at the product. Why? Because there are only so many integers that multiply to give me 6. But when I start talking about two integers that add to give me 5, oh good lord, it never ends. 1,000,000, 5, and negative 1,000,000. 1,000,006 and negative 1,000,001. Or 1 and 6. Or, I mean, you guys get the picture, it never ends. So let's go ahead and set up and say what numbers multiply to give me 6. Well, I've got 1 and 6, or 2 and 3. So those will multiply to give me 6. But now my question is, which set will add to give me 5? Well, 1 plus 6 is 7. That's not what I was looking for, so I know that it cannot be those two integers. Now, if I did this right, I know 2 plus 3 have to give me 5. But let's check it anyways. 2 times 3 is 6, that's true. 2 plus 3 is 5, that's true. So now I come up here, and just like I talked about before, the two integers we found, each one goes on one of those two lines. So I know the factored form of x squared plus 5x plus 6 is x plus 2 times x plus 3. In other words, if I take these two binomials and multiply them together, I will get that as an answer. Ladies and gentlemen, let's go ahead and do one more of these. Again, we'll keep it pretty basic this time though. We will go ahead and switch and make our sum a negative number, but that's okay because it doesn't make it all that much more difficult. So we start off with a sum, a product, and integers. We call this a SPI chart. A sum, ladies and gentlemen, is going to be negative 9. Please note that the sign goes with the number. The product here is going to be 20. So I need to find what numbers will add to give me 20, but will multiply to give me 20, but add to give me negative 9. So I start over here with the integers and we start adding them up. Wow. We start over with the integers and we start multiplying them. So I've got 1 times 20 will give me 20. 2 times 10. 3 doesn't go into 20, then we get 4 times 5. 5 times... Well, wait a second here. You see how this 5 and this 5 match? That means that I've counted up as far as I can. So I don't have to write this 5 because it would just start going 5 times 4 and then 10 times 2 and 20 times 1, and we already have those, so it's not worth wasting our time. Now, if you look over here, we're dealing with a negative sum. So if my product is positive and my sum is negative, how does that work? Well, the only way to get a positive number when I multiply is either a negative times negative equals a positive, or a positive times a positive equals a positive. So if I'm looking for a negative sum, which one's going to make more sense? To have two negative numbers or two positive numbers? Well, here's hoping you actually answered that, or at least thought about it. It's definitely going to be the negative numbers. So let's go ahead and just put a negative sign out in front of each one of these. So now I look. Negative 1 plus negative 20. Let's go back and try adding them now. Will give me negative 21. That's not the sum I'm looking for, so we cross it out. Negative 2 plus negative 10 will give me negative 12. Again, not the sum I'm looking for, so we cross it out. Negative 4 plus negative 5 is negative 9. That is the sum I'm looking for. So I come over here, and this time, instead of putting pluses in, we put minus. So x minus 4, x minus 5. Now, ladies and gentlemen, that's really as simple as it gets. All you need to do is go ahead and practice this. Tomorrow I'll tell you we're going to start talking about what happens when both signs are different. So when we pick our integers, how do we set it up if we know we need one negative and one positive? For today, they'll all be the same. It'll either be two negatives or two positives. Go ahead, work your way through the rest of the PowerPoint. If you have any questions, ask Mr. Rodel, Miss N, Miss Morse, or if you're really stuck, you can always ask to come see me. Make sure you guys are understanding this. Have a great day.